The notation of an inverse function is f to the negative 1. So if you see f to the negative 1, you know that function is an inverse. So that's the notation for it. It's different than we've seen before. Not too terrible of a lesson. Really what we're doing is we're simply switching the x and the y values of the coordinate pairs. Oh, okay. Well, I'm recording. I guess just a video for myself. Okay, so f to the negative 1, can you see it yet? No, still no?
It's coming.
It's coming slowly.
That's like my grades. They're falling.
Max.
You have no grades like yet in this
I can
class.
back that up.
How can your grades be falling when there are no grades?
You have a 0 in this class, Rob?
Yeah, 0.
I mean, Jonah, you have.
You all have zeros right now. Poor Jonah, just sitting there. Just sitting there. Okay, that f to the negative 1, if you see that on a graph, it means that that is its inverse function. The x and the y coordinates have already been switched. So if a graph is labeled f exponent negative 1x, you know that it's the inverse function. Oftentimes I will ask for you to graph the inverse function. On a provincial exam, I've seen them give the picture of the inverse function and ask you to graph the parent, which isn't bad. You just switch the x and the y and you graph that graph, right? So it was people felt it was a tricky question, but if you really thought about it, if you switch the x and the y to get to the inverse, you just switch them back to get to the parent. And so really what we're doing is we're taking the coordinates and we're switching their places. That's all we're doing with an inverse function. So let's dive into it. And I'm going to do a table of values for this just because I think that it'll be helpful just to see the x's and the y's switch. You don't always need a table of values. So this is my table of values for the f of x function. So when x is 0, y is 5. What?
Language, dude, really?
What?
Who's swearing?
Come on.
I don't know, but it's offensive.
Are you freaking me or not, dude?
Again, it was Rahat?
Yep.
I don't never swear.
I would say that that is a false statement.
Out at the front of the school.
Okay, so what I would like you guys to do you guys all know how I got that? That's grade 10. You can graph a line. Can you guys go ahead? Okay, let's graph the parent function just for funsies.
The father function.
Okay, we're going to call it the parent function. Whatever you choose to call it that makes sense to you, Rahat, please feel free to go ahead, but you don't need to correct me all the time, okay? Because it's going to be a long semester. All right, we need to put some increments on here. My y's go to 9.
Oh.
Ugh. Do you guys remember when graphing straight lines was hard?
No, never
I
mind.
still recall.
Do you guys remember when domain and range were hard?
No, it was never hard.
Never hard?
Still hard for me.
Guys, were you like crying over it a couple years back?
Steven, you were crying over a quiz last year.
Hey, we have all cried over a quiz.
No, we have not.
We have.
Not all of us, Miss Stallion.
I'm gonna say that's not a true statement. We have all had emotional feelings about a quiz.
Not really.
Yeah, it's more like science.
Assignments, really? I'm gonna use my handy dandy ruler to connect those lines.
Ma'am.
I'm gonna put some arrows on them because they continue on. And I'm gonna label this function f of x.
I'm on a district.
You use a ruler, Dion?
I don't have a ruler.
Oh,
I got one, bro. Just use this.
Yeah. What?
Yeah, that is too. Why is your ruler sticky?
okay, gentlemen,
Do you want to teach it?
no.
Bro, you literally did not have a ruler. I gave you a ruler at first, and now you're like.
I'd rather not have a ruler.
You use your
Okay.
ruler?
So now to do so you guys want some time to work on your assignment? I'd like to focus on the lesson and not the ruler.
Thank you for the ruler.
So the only thing we have to do here is switch the coordinates. So now x's become y's and y's become x's. So -2, 1 changes to 1, -2. And this would be 3, -1, 5 and 0, 7 and 1, and 9 and 2. All right, so now I'm going to go ahead and graph that function.
Oh, so you like flip it.
Yeah. He's got it.
Don't let me get.
You're on track.
Oh my. You're ruining the progress.
Here we go.
So 2 graphs on the same coordinate plane, so I have to label this one f -1 of x.
This is a straight line, yeah. This is straight. Would you please take that back?
Okay, so what you will notice with inverse functions is that they are a reflection in the line y equals x. So do you guys know where that line is? Y equals x. So if x is 1, what's y? 1. If x is 4, y is 4. It's almost like,
It makes sense.
so x is 2, y is 2, x is 4, y. So this is a line of reflection here. It's the principle, it just goes through, and they always do this. They always have a line of reflection through y equals x.
Yeah, like.
So remember when we were talking about reflecting over the y-axis and reflecting over the x-axis? Inverse functions reflect over y equals x line. They are the same distance away from the line of reflection. So it's where you put the mirror.
So it's kind of like physics.
So please note, when I put the reflection line on, it's not a function, it is a line of reflection. So I used a dash line because it doesn't actually exist in relation to these graphs. So if I want to put that line of reflection on just to remind myself, great, but you're going to have to make sure that it is a dash line. Okay, stop touching each other.
We bumped out.
Oh, I just first time.
Whoa.
When did you rub your elbow?
No, cause look, I was like this, it's my space.
It's right here.
Alex, that's so wrong.
Oh.
Okay, you guys spend so much time having other conversations, I'm not surprised some of you are lost. Okay,
Cat.
We're literally ahead.
all right. You guys reflect that line. Not reflected. We reflected in y equals x, or go ahead and graph the inverse. Go ahead and graph the inverse.
Why is this line not straight?
Is it supposed to be like?
There is nothing saying that it has to be a straight line. An equation wasn't given, right? You're just given the function. So what I'm asking you to do is graph the inverse to that function. What's your strategy?
Oh,
The points, I don't know if the cross is there. Yeah, don't do it.
Does that help if we do that?
I think you can do. What? Oh, it's negative from negative.
So weird.
Oh,
Guys, I just labeled 2 points.
that's given there.
Like this shouldn't be. So do I need a table of values for this one?
Not really.
Not really.
My, like, my mirror.
You shut up here.
I finally agreed with the office.
Thank you.
I disagree. Slims County, what's gonna be the line of reflection?
What is the line of reflection always with inverse graphs?
Come on,
X
man.
equals Y.
Or y equals x, but yeah.
It has to be that.
You got
Yeah.
it on or hot picture today.
But I mean, y equals x runs through here. Is that a reflection?
Yes.
Yeah. So all I did was take this point and what did I do to it?
You reflected it.
I flipped the x and the y, so this became 2, 0. If I flip this point, -2, when I flip it, it's the exact same thing. So that'd be an invariant point. Ta-da! I've graphed it. Okay. Whew. So you need to remember some stuff from grade 10. From grade 10. So you're going to have to dig deep. What makes something a function?
No shared Y values.
No repeated x values. You can have shared y values, but like you can have
X values.
exactly. So you can't have repeated x values. You can't
be
have
flat
points.
on Y.
You can't have points stacked on top of each other.
You can't have a hyperbola.
Right. That's a good example. If we have this as a function, or sorry, if we have this as a relation, is it a function?
No.
Mega poly.
It's not, because it's got points stacked on top of each other. And it would not pass the vertical line test. So if I put a vertical line on this graph anywhere, if it hits more than once, then it's not a function. And we did this in grade 10, so if you don't remember it, that's not a big deal. Okay, so here's the relationship, and most people don't get it. If you graph the parent function, so if I'm looking at, okay, if you graph the parent function, and the question asks you not to graph the inverse function, but it asks you the question, is the inverse a function? You can do it one of two ways. You can graph the inverse and do the vertical line test. So option 1, I don't know where I'm putting this, option 1. Graph inverse, do vertical line test, and decide then. Or option 2, graph the parent and do a horizontal line test. Horizontal line test, everybody knows horizontal runs left to right. Same rules apply. If it hits it more than once, then the inverse won't be a function. Well, it will not be a function. It will then be a relation. Pardon? No, linear just means straight line. So let's go back to this example for a second. Here's the parent function. We've decided that the parent function is, or sorry, the parent graph, is it a function? What did we say?
No.
No. So we know that the parent is not a function. We know the parent graph is not a function. Without graphing the inverse, we can check to see if the inverse is a function. What we then do is we take a horizontal line and we can put it anywhere on the graph. We can draw multiple if we want. So here, I'm applying a horizontal line test. Does it cross the graph more than once?
No.
No, it doesn't. So we know that in this case, the inverse, even though we haven't graphed it, we haven't done any work like that, we just laid some horizontal lines on it, the inverse is a function. So I've seen that question show up on a provincial exam, and it was a 1-mark question, and people got all bent out of shape because they had to graph something and then they had to do the horizontal or the vertical line test, but really you could use the horizontal line test to decide without ever graphing it. Okay. Let's just graph the parent. Let's graph the parent. Can you guys go ahead and graph that parabola? Where's the vertex?
-1, 0?
0, -1.
I forget how to get the vertex.
Is there anything in the brackets with the x?
I can't remember.
Are there brackets?
No.
No. So what number is with the x?
0.
0. And then what number is being subtracted?
-1.
-1. So my vertex is 0, -1.
Oh, okay.
So some of you might want to do a table of values. Really, that's taking the original graph and you're shifting it 1 unit down. It really depends if you want to use a pattern. It's wherever you are on your graphing journey. Like, that's a lot of movement this class.
You made great progress today, Tom.
Like, you've moved a full desk. You now are sitting in front of Jonah.
I like that.
Kick him out. Jump in the back. Bob said he wants to sit by Steve. We all love Steve.
Oh, hell no, he's staying.
Steve?
Answers my
Which
question.
you, Steven?
You knew, you said you wanted.
When did I say that?
Just now.
Dion?
Shut up, Jonah.
Speaking
Jonah didn't say a word.
You know what? We got you on camera.
Oh, shoot. I heard that. Oh.
How'd she get that?
I'm graphing with a pattern.
Oh. Oh my goodness, Miss Gallia.
Oh my goodness. It was easy to do because there was no a value, so I just went 1 away from the vertex, 1 squared up, 2 away from the vertex, 2 squared up. That's what I just did quickly because there was no a value. I find when there's an a value, I have to do a table of values, but when there's not, I can use the pattern pretty quickly. So, parent graph, is it a function?
Parent father graph is a function.
Okay.
Father, how do you know it's not
He's got a point.
It could be that.
What?
Jeez, Rod, you're really a longer than we know that.
Okay, so we are stating for certain that the parent graph is a function, and why? Passes the vertical line test. Okay, it passes the vertical line test. We have no repeats in the domain. Those are 2 things. So we could say that it passed, vertical line test, domain does not repeat. Because that's going to be a thing. The describe or justify why it's a function, why or why not it's a function, that involves this part of it. So if you can't tell me why, you're not going to get full marks. Okay, so now the question is, without graphing the inverse, is the inverse a function?
No.
Yes, it is.
No.
No, it's not. No, it's not. Not bad.
It fails the horizontal lines test.
And so we would say that the parent graph failed the horizontal line test.
But- Oh, my bad.
Or we could say domain values repeat,
What do you say, one or the other?
one or the other. But it's the parent that failed the horizontal line test, not the inverse function. Now, if you graphed the inverse function and you're looking at the inverse graph, you need to apply the vertical line to it. Horizontal line test only applies to the parent. Does that make sense to everybody? It's easy to get mixed up. Sorry. Domain values would repeat. Because now my graph is going to turn like this. It's going to be going, like this will move to here, and then my inverse graph would go like that. So my domain values repeat. It's not my range values.
The domain values of the inverse.
Of the inverse function repeat. Let's write that. Domain values of inverse graph repeat. It's the domain values of the inverse graph, or you could say the range values of the parent, but you need to be really specific if you're going to say range.
So I still
Okay.
say parent graph fails at HL test?
Yep. What's the HL test?
Horizontal line, DL on HL.
Okay, so easy to get confused, but like it just takes a little bit of practice. It makes sense. It's just meant to save you some time so you don't have to graph that inverse graph. Okay. All right, here we go. This is a question on your quiz, and this is a question on, I think it's either on your quiz or on your test. Hint, hint, nudge, nudge.
Yep.
Okay. All right. So, we're going to start there. Actually, so do we know the equation? So this is the x, right? Everybody agree? That's x. Do we know the equation for the inverse function, inverse relation? Do we know it? Nope, we're not reciprocating anything. What did we do with our table of values? What did we do with the table of values? What did we switch? We just switched the position of x and y. So when you do your inverse relation, you are just simply going to switch Now, you could rearrange this to be y equals if you want to.
That's what I was talking about.
Yeah?
It does reciprocate if it's y.
Right, you're right, it will. But did you divide the 6 by 2 as well? Or 6 by 3 as well? So if we were to rearrange this, this is going to be x minus 6 equals 3y. And I left my 3y on the right-hand side just because it was positive. So divide by 3, divide by 3, divide by 3. So now that you have the inverse relation, now you can go ahead and substitute in the 8 into there. Okay? So you can go ahead and substitute in the 8. You can only answer this question once you know this. Now, you could leave it like this and just substitute the 8 in here instead of here, but sometimes questions will ask what's the equation of the inverse, and this is what you would be expected to do. So let's substitute it in. We are going to have 8 over 3 minus 2 equals y. I should have left that as a fraction. 8 over 3 minus 6 over 3 equals y. So we know that in the inverse graph, when x is equal to 8, my y value will be 2/3. That'll be a coordinate on the inverse graph. Hint, hint, nudge, nudge on your quiz. Maybe your test. I can't remember. Okay, this one's super simple. This is grade 10 again. What function is this referring to? The parent or the inverse? The parent. So f of x equals 3x plus 6. Does -4 go in for the x, or does it replace the f of x? It replaces that whole f of x. It's saying f of x, those two letters have a value of -4. And so what are you solving for? X. Is the slope of 1 and going through 0, 0. Yeah. That's the reflection line. Yeah. Okay. Can you guys verify? Can you guys verify that the following functions are inverse functions to each other? Can you do that?
Yeah, I got you. Oh, good.
So what are two ways? You can graph them. You can graph them, and if the points are switched, or it's a reflection in the line y equals x, you know they're inverse. What's another way?
If they're parallel.
No, they won't be parallel if they're inverse.
Oh, no, it'd be, what's the other one?
Well, they could be parallel if they're inverse. That's not a true statement. They could be parallel. But another way is with the equation, just what we did up there. Yeah, but they're almost, but what we did up here was we figured out what the equation was. If I take this equation and I change it, so if I have the parent function of f of x equals x minus 6, to do the inverse, what would be the inverse equation of this one? You guys would agree with me there, right? We just switched the place of the x and y, straightforward, and rearrange this. So this would be x plus 6 equals y. Is that the other equation given? Yes. So we verified using algebra that these are inverse equations. So you guys do the next one. You can choose to graph it, or you can choose to use algebra. How many of you are going to graph it? Okay. You are my visual thinker. The rest of us are just going to rearrange an equation. Does it matter which equation you start with?
Yeah.
No, you just want to see if it matches the one given.
Oh, I understand.
Is that the equation listed above? Yes, it is.
Oh, so you're just flipping swapping the letters.
I'm swapping out the letters. Yep.
And then you're playing with the numbers.
Okay.
I'm not playing with the numbers. I swapped out the letters and rearranged the equation. That's what I did. So all I'm checking to see is if this matches this. Because that, I said, was my parent function. Did you guys use this one? Probably most of you use the f of x. That's why I picked the g of x. So when you swapped the letters, did you get this function? Yeah. So you know that they're inverses to each other. Do we want to graph them?
No.
No, let's not. Let's not. Okay, that's it. That's all. Your quiz is tomorrow.